Okay, so we are going to look at making another, putting another ionic compound into water. So in this case, I'm going to start playing the video. So they are taking copper 2 chloride solid, and she is adding water to her flask and stirring. And what you're going to see is you're going to have a clear, which means I can see through it, um, blue solution, right? So different than what we saw with the copper 2 carbonate, the copper 2 chloride is not settling out to the bottom, and I can tell that because my water would have been clear and colorless, but now the liquid is clear and blue. So that to me is my evidence that the copper 2 chloride would have dissolved in water. Okay, so let's talk about the same topics we would have talked about in terms of our copper 2 carbonate. We want to be able to use our solubility rules. We want to be able to write equations, and we want to be able to draw a model. Okay. All right, so again, if we don't already have them out, we've taken out our periodic table, we flipped it to the side with all the charts, and looked for those solubility rules that are in that lower left-hand corner. Again, solubility rules are listed by ions, so you're looking either for the copper 2 ion or the chloride ion. Copper 2 ion is not in the table. Instead, you're going to be using the chloride ion. In your chart, it says chloride ions are all soluble except, right? And my exceptions are silver and lead and mercury. None of those are copper, right? So this is telling me that they are soluble. Okay, so my equation is going to start out with the same way we looked with copper 2 carbonate. You're going to write the formula of the ionic compound. Now again, I gave it to you here, but the expectation is you can write your own formulas for ionic compounds. It's going to be a solid. We are adding that copper 2 chloride solid to water. That's what you're telling me by writing the H2O above the arrow. Now in this case, it's soluble. So again, if I were to take you back to chapter 8, where we wrote total ionic and net ionic equations, things that are soluble have an aqueous state of matter, and remember that those ionic compounds, when they're aqueous, they break apart into their ions. So this is going to become 2 ions. You have your cation, which is always first, right? So I know the charge of copper based on the Roman numeral. Okay. And it's soluble, so my state of matter changes to aqueous. Right? So again, based on our discussion in chapter 8. And the other ion is the chloride ion. So this is in group 17. It has a -1 charge. Again, soluble, so this is aqueous. Remember from our discussion about total ionic equations and net ionic equations, subscripts are going to become coefficients. Okay, so there's how to write an equation if your ionic compound is soluble. All right, let's take a look at my model. So again, we're going to have copper plus 2 ions. And then again, we're going to need to have chloride ions. Okay. Now again, my drawing here, you can imagine that this is my test tube or my beaker, whatever your scenario may be. And so you have 1 copper ion according to your equation, so there's my copper ion. And according to my equation, I'm supposed to have 2 chloride ions. So there are my 2 chloride ions, right? This is soluble, so nothing is connected together. The ions are all, remember that in order for us to have single displacement and double displacement, you have to have ions that can move around so that they can trade partners, right? So here are my ions that are able to move around so they could trade partners when we talk about that single and double displacement. All right, so I'm going to draw my model, right? So I have my 2 chloride ions and my 1 copper plus 2 ion in solution. Okay, expectations, right? You should be able to use solubility rules to determine if your ionic compound is soluble or insoluble. You should be able to write me dissociation equations. You should be able to draw me a particle level diagram of your compound, no matter if it's soluble or insoluble.